We're in hardware, and that is going to be computer hardware. And let's see, what are we going to start out with? Examining the block diagram of a practical computer system based upon a microprocessor will be useful in understanding its operation. A system level block diagram is illustrated at the right. And so here we have a block diagram of a basic computer system, and this will be the subject of this particular section. And let's see, we're going to be looking at, we have a microprocessor here, then we have a system controller. This is usually referred to as a chipset. Internal memory, this is usually referred to as RAM. And then cache here, that would be both level 1 and level 2 cache. Then over here we have the video controller, video card, etc. Then the hard disk controller, USB circuits. Then down here we see the Ethernet circuits, power supplies, ISA bus, PCI bus, BIOS, etc. But this will be the subject of this particular section. Okay, the major functional blocks in a computer system communicate via a number of buses. And so there are three major buses represented in the diagram. So here we see the AGP, the PCI, and the ISA bus. PCI will be the first one we'll mention. This is referred to as the peripheral component interconnect, and it is a bus of moderate speed. Usually this is about 33 megahertz, but we will look at this more in the next slide. Then there is the ISA, which is the industry standard architecture. It is a much older than the PCI, but also provides for a standard communications path. And so ISA has been around ISA was around from the very beginning of PCs. It is beginning to fade from the newer systems. Most of them are going to PCI and USB as the primary buses. Then there is the AGP, which is an acronym for Accelerated Graphics Port. This would be right here. And this provides high-speed video information between the system controller and the video controller. Now, for a little bit closer look at the standard buses, I have a table built here. And we're going to look at ISA, PCI, AGP. And first of all, the ISA bus, it can be 8 or 16 bits wide. What that means is that you have a bus, and if it's 1, 2, 3, 4, 5, 6, 7, 8, it means that when data is moved on this particular bus, if it's 8-bit wide, it means that there's 8 lines. And so what that means is that we could have a byte of data, say we had 11001011, and we wanted to move this byte on the bus. We would move it in parallel on a given clock cycle. If there's one clock cycle, then this entire byte moves on the bus at one plane. So it would be moved around the system board to different devices, but 8 bits would be moved simultaneously. Now that's in the case, actually that was on the first PC, which was an 8-bit machine. And then along with the era, and this is really dating systems, but along came the 286, which was a mighty 16-bit machine. And so then you can do the same thing, only you did it with 16 bits. Now the clock speed for this system is about, for the ISA, is 8 megahertz. Technically I believe it's about 8.3, but for our purposes we'll just say 8. And so you're moving, in this case, either 1 byte or you're moving 2 bytes in this case. And this is in recent years, this has been usually ISA is a 16-bit. This is really old, went back to 8-bit. But if you do the math here and you figure out, well, how much data is actually moving. And so we're moving 2 bytes at a time on the bus, and the bus is moving at about 8 megahertz. So 8 times 2 would give us a 16 megabyte throughput. And so this is often the way that we evaluate buses, is what is the total throughput, how much data can we move through this bus. And so in this case with ISA we're looking at 16 megabytes per second. Now there actually is an error. Your text is really quite good, but there is an error here. It says 1 to 2, and actually it should be 8 and 16. I think they're getting confused with the bus width, and they weren't thinking in terms of a transfer rate. Okay, the PCI bus came along, and the standard PCI bus is 32 bits wide, and it operates at 33 megahertz. Now, that gives us an effective throughput of 133 megabytes per second, which is quite an improvement from this. And we get that number from, if you think about 32 bits, that's going to be 4 bytes, okay, 8 bits per byte, and then times 4, okay. Anyway, so we would be moving, we'd have like this, only we'd have 32 lines, and we'd be moving at a much faster speed. It's 33, actually it's 33.333, and that makes this math actually work a little better. But if we took this frequency times 4, then that's where we come up with this number. And so this is our effective throughput for the PCI bus. Now, before PCI, ISO was the primary bus that was used for video. And note that there's quite a difference here, that in speed, that this is going at 16 megabytes, where this jumps all the way up to 133. So that's why when the PCI video cards, it was quite an improvement over the ISA performance with video. But then along came AGP, and before I jump to AGP, I will note here that there are some specialized PCI buses. Oftentimes in servers, they will have an advanced bus that will actually be 64 bits wide, and sometimes it will go as fast as 66 megahertz, and so this would make for a much faster PCI interconnect, but most commonly it's 32 and 33 megahertz. 32 bits. Okay, now the AGP came along, and this was Intel, and actually both of these were Intel inventions. And the AGP moves data at 32 bits per second, or 32 bits on the bus. So same as PCI. So you'd have 32 lines and moving 4 bytes at a time. But notice the speed. The speed is twice that of the standard PCI bus, and so because it is twice as fast, then the throughput is actually going to double. So we had 133 coming out of our PCI, but the AGP jumps that up to 266. And so, for purposes of video, when you think about the changes that have taken place, went from 16 megabytes to 133 all the way up to 266. Now, this actually represents what we would call AGP 1, when AGP first came out, and your text mentions going up to actually 1 gigabytes, but actually the speeds have gone higher than that. So let's jump to the next slide. And this is some information. Actually, this is quite accurate. I got this from Wikipedia, even though Wikipedia isn't the most accurate source. This is quite accurate in concern to AGP. And so let's take a quick look at this. AGP1, it started out with 32 bits operating at 66 megahertz, resulting in this was our throughput of 266 megabytes per second. And it doubled from the 133 megabyte bus, which we saw on the PCI. And then the next rendition was the clock doubled, and so AGP2 came along, and again 32 bits at 66 megahertz, but they clocked it a little bit differently, and they were able to double this speed. So it went from 266 now to 533. And so this was the AGP 2X series of cards. And then it went to 4X, which went from 533 and doubled it to 1066. And that's where your text leaves off. But actually AGP is in 8X. And so in 8X, there is a doubling of that up to around, it's the same, 2133 megabytes, which is 2.13 gig. And so this allows for some very serious bandwidth in regard to video. It makes possible many of the intense graphics that we see today that come from high performance video cards. Okay, so this was a quick intro to the AGP, and we looked at the standard buses that you see in PCs, and we just basically introduced the subject, and we'll continue on with other hardware in the next presentation.